Today we are talking about prime factorization. All right. This is a very good key tool for you to learn in high school, especially whenever you move on to quadratics and things like that. You need to know how to factor and be able to factor things quickly. So prime factorization, because 3 is a factor of 24 and 3 times 8 is 24, then 8 is also a factor of 24. The pair 3, 8 is called the factor pair of 24. Prime factorization of a composite number is the number written as a product of its prime factors. Prime numbers 1, 2, 3, 5, 7. Things that basically the only factors is 1 and that number. Those are prime factors. You can use factor pairs and a factor tree to help you find the prime factorization of a number. The factor tree is complete when only the prime factors appear in the product. So let's look at your first example. So example 1, right? Example 1, a classroom has 42 students. The teacher arranged the students in rows. Each row has the same number of students. How many possible arrangements are there? Okay, so factoring this out, you have 42. You have 42. And so factoring, right, you got 1 in 42. 2 goes into 42 21 times. 3 goes into 42 14 times. Let's see if 4 works, right? Does 4 work? 42, I'm just using a calculator. 42 divided by 4 is 10.5, so that doesn't work. 5 doesn't work because it doesn't end in a 0 or a 5. 6 works because 2 and 3 work. So if 2 and 3 works, then 6 works. So that is 6, and we know that is 7, and there is no fractions in between there. So how many possible arrangements? Okay. You can have basically this. You can have one row of 42 desks, or you can have 42 rows of one desk, 2 rows of 21, or 21 rows of 2, 3 rows of 14, or 14 rows of 3, 6 rows of 7 desks, or 7 rows of 6 desks. So there is 8 possibilities. All right, 8 possibilities. Prime factorization. So it says choose the factor pair of 54 to begin the factor tree. All right, so it doesn't matter for 54. It doesn't matter which one that you choose. There is 3 and 18. There's 2 and 7. All right. Another one that we may know is that we may know this as 6 times 9, right? So we can factor it that way. The factors of 6 are 2 and 3. Those are prime. The factors of 9 are 3 and 3. So we still get 2 times 3 times 3 times 3 equals 54. All right. So the prime factorization is still 2 times 3 times 3 times 3. We know with our works with exponents, and if you don't know that, we'll have a video on exponents. We know that if we are multiplying like bases, we can add the exponents, right? Those all have a 1, so that can be 2 times 3 to the third equals 54, 54, right? So we can write it that way. All right, so here are some practices. If you want to pause it, and go ahead and get these practices done, or if you're just here to get some help from math hints or just to get answers, I suggest that you pause it, try these out on your own so that way you can learn and then check your mistakes. You don't get anything by just copying answers. It goes in, it goes out. It doesn't benefit you any. All right, so list all the factor pairs of 16. So we have 16, right? We have 16. 16 is 1 and 16. 2 times 8. 4 times 4. And that's where it stops. 30. 30, we have 1 times 30. We have 2 times 15. We have 3 times 10. 4. Let's see. 4 doesn't work because If I double the 2, half the 15, that's a decimal, so it doesn't work. 4 doesn't work. 4 goes into 3 0 times, right? So the 4, 4 times 7 is 28. 4 times 8 is 32, not 30. 5, let's see, 5 works because it ends in a 0, so 5, and that would be 5 times 6. All right. 63, again, 1 and 63. It's not even, so 2 doesn't work. 3 works. 3 and pop that into my calculator. 63 divided by 3 is 21. So that's 21. Uh, 4. 4 doesn't work because 2 doesn't work. 5, this is not a 0 or a 5, so 5 is not going to work. 6 isn't going to work because 2 and 3. All right, 2 doesn't work, and 2 and 3 has to work in order for 6 to work. Let's try 7. I'll pop it in the calculator, and 7 times 9. That works. Okay, I'll go with a different color here so that way you can see the 100. 100 is going to probably have a good bit. So we have, I'm going to have to write it vertically here, horizontally. 1 and 100 divided by 2, I get 2 and 50. 100 divided by 3 does not work. It gives me a decimal number. 4 will work, so that's going to be 4 and 25. We know 5 works because it ends in a 0. That's 5 and 20. All right. 6 doesn't work because 2 and 3. 7 doesn't work. I divide that in a calculator. It gets a decimal number. 8 works because 2 and 4 work, so we know 8's going to work. 8 will give you, will 8 work? No, actually, I don't think 8 works. No, 8 doesn't work. I apologize. 8 doesn't work. 8 does not work. 9 doesn't work, and 10 works with 10 times 10. All right. 135. Again, I just punched these in my calculator. We know that 1 and 135 work. 2 doesn't work because it's not even. 3 works. 3 is 45. 4 doesn't work again because it's not even, but it's also, it ends in a 5 there. Anything times 4. 4 times 5 is going to give you a 0. Anything with 4 that you multiply by 5 will give you a 0. Anything times 10 with the 4, it'll give you a 0. Let's see. 5 will work because it ends in a 5. And that's 5 times, calculator says 27. 5 times 27. And so then, see, 6 doesn't work because 2 and 3 doesn't work. Try 7. It's a prime number. So let me try 7. Let's see. 8 doesn't work. And then 9 works. 9 will give you 15. And that's it. All right, so 275. 275, of course, with 275. We know 1 and 275 is going to work. 2 is not going to work. Let's see, 275 divided by 3, that doesn't work. 275 divided by 4, that doesn't work. 275 divided by 5, that works, and I get 55. Right, so that's 5 and 55. 6 isn't going to work, so let me try 7 because it's a prime. Let me divide it by 7. Nope, 7 doesn't work. 8's not going to work. 9's not going to work because it's not a factor of 3. Let's see, 10, it doesn't end in 0. Let's see, let's try 11. That's my next prime. 11 works. It ends in 25, right? My next primes after that would be 13. 13 doesn't work. Then it would be 17. 17 doesn't work. 19 doesn't work. And 23 doesn't work. So there we go. There are those. All right, so what I'm talking about prime factorization is, again, when I have 24, you get it down to its prime numbers. 24 is 3 times 8. 8 factors down to 2 times 4. That factors down to 2 times 2. So the prime factors is 1, 2, 3. That is 2 to the third times 3. That is the prime factorization of 7. All right, so 66. 66, we know that's 6 times 11. 11's prime. This is 2 times 3, so that would be 2 times 3 times 11. 50. We know 50, 5 times 10. And that would be 2 times 5. Here, let me zoom in a little bit on this so that way we can, looks like we have a little bit more room to write whenever I can zoom in. There you go. All right, and so that'd be 2 and 5. So this would be 2 times to the second. 80. 80 is the easy way to go there, would be 8 times 10. That is 2 times 4, which is 2 times 2. 10 is 5 times 2, so count up your factors. 2, 1, 2, 3, 4, so that's 2 to the fourth times 1, 2, 3, 4 times 5. All right, I'll go with a different color. All right, let's do 98. Let's now do 98. 98. All right, so we have 98. Uh, 98. I don't know nothing off the top of my head, but I know 2 works, so I'll just pierce this thing down. I don't know anything off the top of my head, but 2 is 49. Ooh, 49. 49 is a perfect square. If you don't know what that is, we'll have a video coming up on that, okay? Look up perfect square. But perfect square is that 49 has a number divided by itself or multiplied by itself is 49. So that would be 7 and 7. So that would be 2 times 7 squared. 126. 126. What's 126? Let's try 6. 126 divided by 6. Oh, it works. This is 6 and 21. That is 2 and 3. This is 3 and 7. That's all prime. So I'll have a 2. 3 to the second times 7. 154. Ooh, 154. Again, 2 is going to work. I know 2 will work. So that will be 2 and 77. Wow. 7 and 11 works, and that's prime. So it's 2 times 7 times 11. That's your prime factorization there. That one was actually a lot easier than I thought it was going to be. Let's see here. We have 310. 310. I know 10 works, right? So let's say 3. We know 10 works. That's 10 and 31. 31 is a prime number, so that stops. This is 2 and 5. There's my prime. So this is 2 times 5 times 31. Again, big number, but factorization for it is pretty simple. So now this is looking for, again, what is the greatest perfect square? Again, a perfect square is like this, right? 1 times 1 is 1, right? But 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. I'm not going to keep writing it out, but 7 squared is 49. 8 squared is 64. And 9 squared is 81. You really need to know these all the way up to 15 squared. You need to know these all the way up to 15 squared. But 1, 4, 9, 16, 25, 36, 49, 64, 81, all right, 100, all the way up to 225, right? And it keeps on going. Those are called your perfect squares, okay? So what it's asking is, hey, what is my largest perfect square? How do you get those? When you have an instance of this right here, right, where you have 5, right, where you have an instance of 5 squared, right? 5 squared is 25, right? So that is your largest perfect square. So that's all you do. So I'm going to factor this. Let me change colors. 117. 117, 2 doesn't work. I know that. 117 divided by 3. Hey, look, it works. That would be 3 and 39. And I know another 39, 3 can go into it as well. So that would be 3 and 13. So the prime factorization is 3 squared times 13. So 3 squared is 9, so 9 is your greatest perfect square. That's how you do these. All right, so we got 150. 150, that would be 10 and 15. That would be 2 and 5, 3 and 5. 2 and 5, 3, and so that would be 2 times 3 times 5 squared. 5 squared is 25, so that would be 25. All right, so that would be 25. All right, 539. That number is gigantic. 539. Let's see, 539. Prime factorization. 3, I don't think 3 works. Let me divide it by 3. Yep, 3 doesn't work. 5's not going to work. Let's try 7. 539 divided by 7. Ooh, that does work. I have 7 times 77. That's 7 times 11. So that's 7 squared times 11. 7 squared is 49. So my answer is 49. 936. I almost think I can see my answer. If I had to guess, 36 is perfect, so I would almost guess 36 is probably going to be my answer. Well, let's just see. 936 divided by 36. So that is 36 and 26. That's 6. That's 6. 26 divided by 2 is 13. Right? So that's 2 and 13. So yeah, I actually was right. 6 squared, the 2 goes in front. 13. So that is 6 squared, which is 36. And that is your answer. All right. And that is prime factorization in a nutshell. All right. I look forward to talking to you, seeing you in our next video. All right. Thank you.